Okay. Okay, girls. Let's take a look at this question. Car traveling around a bank. Okay, so here's what this is how we set it up, okay? So you have your normal force. We talked about where you have the vertical component of normal force and the downwards component of gravity and friction. That has to equal 0. So here is the setup for the vertical force. Normal force, vertical component minus the weight minus the frictional component, which is the same as mu Fn, times the angle. Then we have your centripetal calculation, which is mv squared, and that has to equal these two components, which is the normal force sine 45 plus friction cosine 45, whereas friction is mu Fn. So now, what we'll do is this. We're going to set it equal to m. I think that's probably just cleaner and easier. So I'm going to look at the first equation, and I'm going to rearrange it and say mg is equal to Fn cosine 45 minus 0.3 Fn sine 45. Then I'm going to get rid of the g. So I'm going to make that one equation. I'll look at my second equation. I'm going to basically isolate for m again. So I'm going to say m is Fn sine 45 plus Fn cosine 45. So that would be times r over v squared. Now we have my two equations set to m. Okay? So now I will set these two equal to each other. But actually, yeah, let's just do that. Just set them equal to each other. So Fn cosine 45 over g equals Fn sine 45 plus 0.3 Fn cosine 45 times r over v squared. But look, I have Fn everywhere, so I can actually cancel. I can factor out the Fn. So that will cancel out because I can factor out an Fn. So enough with this. Now I can isolate for v squared. I can move v over here. I can move the v squared over here and rearrange this equation and set it up this way. So I'm going to get rid of the g, I'm going to move it to this side. I'm going to get rid of the v squared and move it to this side. And now I'm going to get rid of this. So it's going to be sine 45 plus 0.3 cosine 45. And that is over cosine 45 minus 0.3 sine, sine 45. Yeah, times Rg. And now I can just solve for v. So if I take the square root of all of this, where r is 40 and g is 9.8, my answer is about 27 meters per second. Okay. I think it's probably just easiest to set it up as equals to m. Which one? I divided it on the other side. So the equation was mg equals Fn cosine 45 minus 0.3 Fn sine 45. So I divided by g on this side, and moved it to the other side. So there's the answer for the second question. Should be 27. Okay. Next question. We have a satellite placed in orbit such that it orbits the Earth twice a day. Okay. What's the period if it orbits twice a day? What was the period for one day? How many seconds was it? It would have been, what, 24 hours times 60 minutes times 60 seconds. And this obviously would be, if it orbits twice a day, then the orbital period would actually be half of that, right? So it would be divided by 2. So I think it was like 86,000 seconds, so it should be 43, I think. Okay. Alright. How far from the surface of the satellite how far from the surface should the satellite be if we want that period? What's the equation we could use when we have the period? What is it? Sorry? Over t? Over t squared? That's for period, and then we have to set that equal to what? Which is, so this will be, so what Earth would be M2. I guess you can call it M1, but let's still call it Earth M2. Will be Earth, and M1 will be the satellite. It's not geosynchronous, because geosynchronous means the period is exactly the same as the period of the Earth. So it's not going to be. So whenever we want R, so let's rearrange this equation. Let's get rid of the R, move it over here. So we have R cubed. And let's cancel out M1. Let's move t squared to this side. And then let's get rid of the 4 pi squared. So the equation should be R cubed equals big G M2, which is basically the planet, times the period squared over 4 pi squared. Okay, so let's work that out. So big G is 6.67 times 10 to the negative 11. Planet is about 6 times 10 to the 24. The period is 43,000. That would be squared over 4 times 3.14 squared. Remember, you're taking the cube root of this. So what would R be? What'd you get for R? No, she's away this week. Yeah.
No.
So what'd you get for R? 2.7 times 10 to the 7. And then remember, if you want to know how far from the surface, then you can take away the radius of the Earth, which would be half the diameter. So that would be 6,000 kilometers. 6,000 kilometers is 6 times 10 to the 6 meters. And then you'll get your, so the answer should be 2.1 times 10 to the 7 meters. Okay. Yes. No, that. Sorry. What was the question? The radius. Yeah. So this is the radius, right? So that's R, but the satellite is here, and the distance that you work out for this R is the distance from here to the center of the planet. Okay? So we got to subtract the radius to figure out what that distance from the surface is. Yeah. So this is the radius of the Earth. So if the diameter of the Earth is 12,000, the radius would be 6,000 kilometers, right? But 6,000 kilometers is the same as 6 million meters, because you're going to multiply that by 1,000. That's what this is. Right? Because we want to know, Kiara, we want to know this distance from here to here, right? So the answer that you get from this equation, this one right here, that's from the satellite to the center of the Earth. So we have to take away the radius of the Earth, which is this, to figure out what the distance is from the surface. Okay? And then we have one last question. Okay. This is so ride where you haven't. The riders are pinned to the wall, so that means that they won't slide down. Okay. So imagine that this is the rider, and this is the wall, and the radius is 10 meters. So the ride is turning like this, okay? And the rider is pinned to the wall, which means they don't slide down that wall. So if they don't slide down that wall, that tells you something about friction and gravity, right? Because if it's not sliding down, that means it's not moving. If it's not moving, it means it's not accelerating. If it's not accelerating, that means that the net force is 0. So if the net force is 0, that must mean then that FF equals FG, correct? They have to be equal. Because if it's going to slide, it's going to slide down. So the motion or the direction of the friction vector should be opposite of that.
Which way is the ride?
It doesn't matter. Okay. So the ride is turning in a horizontal direction, not a vertical direction, right? So the ride is turning. So the axis of rotation is horizontal. But if you think about the person sliding off the wall, that would be this way because of weight. But if it's not this way, that means there's another force acting the opposite way, which must be friction. No, okay, so what's happening in this scenario is we know that there's centripetal acceleration pointing this way, right? But remember we said there's that illusionary force, which is the force that you would experience almost as if you're being pressed against the wall, right? So what do you call that force if you're being pressed against a surface? Wouldn't that be the normal force? Right? And doesn't the normal force tell you something about friction? Because we know there's a connection between friction and normal force, right? We could say that mu Fn is really the weight. Now what we can do is we can ask the question, so what's causing this person to rotate in a circle? What would the force be then Yeah, but what would it be? It would have to be the normal force. It's the same as remember the scenario with the marble in that little circle you guys were spinning around? Why did the marble travel in the circle? Because of which force? It was the force of the wall of the container, which is the normal force. So then the normal force is really the weight over mu. And that has to equal what? The centripetal force, which is mv squared over r. Now we're asked for actually frequency. So do you want to use the frequency equation instead? We can do that. Instead of using this equation, what's the equation with frequency? Sorry, yeah, 4 pi squared, yeah? Yeah? F squared? Okay. So instead of using, if I asked you for the speed, you could use this equation. If I asked you for the frequency, you can always work out the frequency after, but if you have an equation with frequency, just use it. So we're looking for F. So I'm going to rearrange this and isolate for F. So it's going to be F squared is going to be the weight over mu times 4 pi squared m r. Now, the weight is the same as what? mg. So m is going to cancel out. So our frequency is going to be the square of this. It's going to be the square of g over mu 4 pi squared r. So what do you get for that? Is that close to 3, the answer? No. No, it should be 0 point something. 0.35? How did you do it different? What did you do? Okay, this is the right equation for frequency. 4 pi squared mr squared. Should work. Okay, I'm going to stop the video here and we'll see why the answer is different.